Okay, so today we are going to review how to multiply by a single digit number and also how to multiply by a multiple of 10. So the first thing we're going to do is go back and talk about the vocabulary associated with the multiplication problem. Normally, we're going to be using the terms factor times factor equals the product. The product is the answer to a multiplication problem. The factor is one of the numbers in a multiplication problem. If we wanted to be more specific, the first number in the multiplication problem is called the multiplicand, and the second number is called the multiplier. Again, the answer is still called the product. Do remember that the commutative property applies to multiplication. So as an example, 5 times 3 is the same thing as 3 times 5. You get 15 in the end. Okay, so let's say we had the problem 23 times 257. I know this doesn't really apply to multiplying by a single digit or a multiple of 10, but it's a good example of a problem that I see a lot of students have when they see a problem written horizontally. When you go to rewrite the problem vertically with one factor on top of another, a lot of times students will want to write it this way. Put the first number on top and then the second number on the bottom. This is true. You have to do this if it was a subtraction problem, but going back to the fact that multiplication is commutative, you don't have to do it this way with a multiplication problem. More times than not, students will answer this problem incorrectly because the multiplication is harder to do if the larger number is on the bottom. So what I will ask you to do is rewrite the problem so that the larger number is always on the top and the smaller number is the second number. And that should give you at least a better chance of getting the correct answer. Okay? So when we are multiplying by a single digit number, for example, we have 465 times 8. We want to rewrite the problem vertically with the larger number on top. So here I wrote 465 on top of the 8. And then we're going to start multiplying all of these numbers by the 8. The first thing we have to multiply is the number in the ones place, which is the 5. 5 times 8 is 40. So I carry the 4 over here and the 0 down here for 40. Then I multiply the number in the tens place, the 6, by the 8. So I do 6 times 8. 6 times 8 is 48. And I have to add anything that I carried. So 48 plus 4 is 52. The 5 gets carried over and the 2 gets written down. My next step is then to multiply the number in the hundreds place, in this case is a 4, by the 8. 8 times 4 is 32, and then add anything I carried. 32 plus 5 is 37. So 465 times 8 is 3,720. Okay, so if we were to do this example step by step, the problem is 7 times 3,409. The first thing I'm going to want to do, remember, is to write the problem vertically with the larger number on top. So I would rewrite the problem so it looks like this. 3,409 on top of the 7. The second thing I want to do is multiply the number in the ones place by the 7. In this case, it's a 9. 9 times 7 is 63. So I write the 6 on the top and the 3 underneath. I have to carry the 6 over. Third thing I do, multiply the number in the tens place, this time it's a 0, by the 7. So 0 times 7 is 0, and I have to add the 6 that I carried over, and that gives me a 6. I don't have anything to carry over this time, so I go on to my next step. I multiply the number in the hundreds place, this time it's a 4, by the 7, and I'm going to add anything carried over from step 3. Well, I didn't have anything carried over, so I don't have to worry about that part, but I do have to do the 4 times 7. 4 times 7 is 28, so I write the 2 on top and the 8 underneath. And then in this case, because I have a number in the thousands place, I have to go and multiply the number in the ones, or excuse me, the number in the thousands place, the 3 by the 7. And again, I'm going to have to add anything that I carried over. So 3 times 7 is 21, and 21 plus 2 is 23. So my answer for 7 times 3,409 is 23,863. Okay. Now we're going to take a look at how to multiply by a multiple of 10. And a multiple of 10 is any number that ends in either a 0 or zeros. So anything that ends in a 0, like 80, 90, anything that ends in more than one 0, like 200, 300, 400, could be even 6,000 or 7,000. Those are all multiples of 10 because they end in zeros. So how I do this is I'm going to multiply the two numbers and I'm going to ignore the zeros on the end. So for example, 4 times 8 I know is 32. That means that 4 times 80 would be 320. Notice that I have 1 0 here, 1 0 here. 4 times 800 is 3,200. Again, 4 times 8 is that basic 32. 2 zeros here, so I have 2 zeros here. And then 4 times 8,000, same thing, 32, but in this case I have 3 zeros. So I multiply the two numbers and I'm ignoring the zeros on the end for the moment. After I get done with the multiplication, I count the number of zeros on the end of the number or numbers. And then I add the same amount of zeros onto the end of the product when I'm done. So we're going to try a couple examples and we'll see how they go. So we have several different examples here, all different types of problems that you could see. 7 times 300, 64 times 600, 20 times 50, 400 times 80, 204 times 30, and 330 times 90. These all have at least one multiple of 10 in the problem because at least one of the numbers always is ending in at least 1 0. Okay? So again, the first thing is I'm going to do is I'm going to focus on the non-zero numbers. And I'm going to ignore the zeros for the time being. So in this one, I'm only going to focus on the 7 times 3. Here I'm focusing on 64 times 6, 2 times 5, 4 times 8, 204 times 3. Why am I focusing on this 0? Why did I include that? Because it's not on the end. It's in the middle. So I have to include it here. And then 33 times 9. That's the only multiplication I'm actually going to worry about. I know that 7 times 3 is 21. I can figure out that 64 times 6 is 384. I can figure that out because I know how to multiply by a single digit number. We just reviewed that. I know 2 times 5 is 10. 4 times 8 is 32. 204 times 3. I would have to figure that one out as well, and that would work out to 612. And 33 times 9. I'm going to have to work that one out as well. I don't know it off the top of my head, but I do know that I can figure it out, and that would be 297. So when I have my multiplication part done, then I go back and I'm going to look at my original problem, and I'm going to count up how many zeros are in both numbers. I have 2 zeros here, so I need 2 zeros here. 2 zeros again in this problem means 2 zeros here. This problem is a little unique. I have a 0 in the first number and a 0 at the end of the second number, which means in my entire problem, I have 2 zeros. So I need to put 2 zeros on the end. Here again, I have 2 zeros in my first number, 1 0 in my second number, which means I need 3 zeros in my answer. Again, this one is in the middle here is a little bit more challenging. This 0 in the middle, I don't worry about counting that one at this step. I only count the zeros that are on the end of the number. So in this problem, I only have 1 0 that I have to count. And that goes on the end. That goes on the end here. In this last problem, I have 1 0 here, 1 0 here, which means I need 2 zeros in my answer.